Finding slope from a graph. In this video, I will go through several examples of how to find slope from a graph. As always, you can pause the video to take notes, or you can just watch depending on the instructions. Some key reminders: slope is the constant rate of change or steepness of a line. Only straight lines have slopes. We use m to represent slope. We always read slope from left to right, and any 2 points on a line is infinite, will give you the same slope. We think of slope as the rise or change in y over the run or change in x. And you'll often see it written like this, which is delta y over delta x. In terms of the signs of slope, when you have a line going uphill to the right, we see some here, that's a positive number. If you see the line going down to the right, that will be a negative number. Slope will be a number. If it is a horizontal line, the slope is 0, and the only time slope is not a number is when we have a vertical line, in which case we say the slope is undefined. Now let's look at some examples. So when you're finding slope, you can pick any 2 points on the line, and we're figuring out what the rise is over the run. Sometimes it might give you a prompt, like think about the slope type. Since this line is going up to the right, I can imagine if I was going to the right, I'd be going uphill. The line is increasing, so it's a positive slope. That's just to remind me that whatever I get as my number will be a positive number. So I can pick any 2 points on the line, and I need to figure out how much do I go up and then over, or down and then over on my grid lines to get to another spot on my line. So in this case, my rise is 2, and my run is 5. So my slope is 2 over 5. That tells me that every time x, this is my change in x, and this is my change in y, every time x increases by 5, as we move to the right 5, y is also increasing, so it increases by 2. Some things I want to point out are how we would count. So you might count by going 1, 2, and then 1, 2, 3, 4, 5. This here, again, was our difference in our two y values. We actually went from the y value 4 to the y value 6 here. And then this was our change in our x values, or the run, because we went from our x value of -5 to 5. So it went up by 5. We'll do another few examples. And just to point out, it doesn't matter which 2 points you pick. So if I had instead picked 2 points that were farther apart, maybe I picked this point and this point, I would have had 4 over 10, and 4 over 10 would still simplify to 2/5. It doesn't matter what 2 points on the line you pick, it will always give you the same slope or rate of change. So on the next graph, I can see that there are 2 points marked for me. And we'll do the same thing, but one strategy, if you are having trouble figuring out where to count, draw a vertical line through one of your points. I'd suggest the leftmost point, and then a horizontal line through the other point. I would suggest the rightmost point, and create a triangle for yourself. It might make it easier for you to see what lines you're counting here. So in this case, we go up 1, 2, 3, and over 1, 2, 3, 4, 5. So our slope here is 3/5, and we double check, yes, it was a positive slope, so it makes sense to have a positive number. So every time we move to the right 5, or x increases by 5, y increases by 3. We'll skip to one on the right here. I can see that as I go from left to right here, I'd be going downhill, it's decreasing. Therefore, the type of slope here is negative, and right away I'll put a negative sign, because all that's telling me is that my slope will be negative. I will have a negative sign in my number here. I see 2 points marked on my line, and I actually see that I could add more points and the pattern would still continue. Imagine like a staircase here. So I could use my 2 original points and simplify, or I could use points that I marked here, so I don't need to simplify. So I will choose to use these 2 points, and I can see that if I start at my left point, I will go down 1 and to the right 2. So my slope is -1/2. If I had used the original 2 points, these 2, I would have gone down 2 and over 4. And we know that -2/4 is the same thing as -1/2. So in this case, my x is still increasing, so I'm still going left to right, but my y is decreasing. So as x increases by 2, y decreases by 1. I like to always write my sentence with the most simplified form of my slope there. It wouldn't be wrong if you said as x increases by 4, y decreases by 2, but if we can simplify, that's our best answer. Sometimes you will be given a graph that does not have all of the points marked. And so what's important is that you find points that are spaced in a way that you can continue the line. So I'm going to draw one that looks like it might be close to the line, but isn't actually. If I mark this point, then I should be able to continue this pattern, and I can see that I get further and further off the line here. So I know that that is not a correct point. So I need to look really closely and look for where my line crosses at exactly an intersection. And again, then I will find the slope. So I can see that this slope is negative, so I'll put a little negative sign right here so I don't forget. I figure out that going from any two of these points, because my line is infinite, if I start at the left, I'll do my triangle method again in case that's something that's helping you. I'm going down 1, 2, 3, and over 1, 2, 3, 4. So my slope is negative 3/4. Again, this is our change in y over our change in x. So no matter what 2 points on the line I picked, I would see that my y values went down by 3, in this case from 1 to negative 2, and my x values went over by 4, in this case from negative 1 to 3. So as x increases by 4, y decreases by 3. So that's how we'd find slope on a basic graph. Depending on what you are asked to do, you may or may not watch the next examples. So the next examples I'm going to show you on a graph with context. So I can see here the graph is titled Movie Mania. It says total money spent and number of snacks. So I can see that based on the number of snacks, the money I spend is going up at a constant rate, which means I'm paying the same amount of money per snack. I also paid some amount of money at the start, which I imagine, given that it's titled Movie Mania, was the amount for the cost of my ticket. So we have a bunch of different strategies we can use here. One thing that I would recommend that you do is that you fill in your scale, your increments at the start. It will make it easier for you to identify some of the points on the line. And then mark 2 points, and we have a few options here. So one option is a mini table. This is actually my favorite method, where I write out the 2 or more, but I can write out any 2 points I see. So I'm going to write out the point 112 that I marked and the point 424 that I marked. So again, this was the point 112 and this was the point 424. I find that in the table, it's easier for me to see, oh, my y, which in this case is my money, changed by going up 12. And my x, which in this case was the number of snacks, changed by going up 3. So that would happen over and over if I added more points, like this point and this point, to my table. So I would say that my rate here is $12 for every 3 snacks, or $4 for every 1 snack. My slope here is 4. And I would even stick some labels on here. So again, it was $12 for every 1 snack, and that will help you to write a sentence. Maybe you use the label. So the total money spent increases by $4 per snack. You might say per snack, or for each snack, or for every snack. We usually see those words right before whatever our X is here. A different strategy would be to figure out what are we counting by. So we saw that each box, if I were to take just like this box right here and do it over to the side here, it was going up by 6 for y and up by 1 for x here. So I could still draw in my rise and my run, or my change in y and my change in x, but you might think it's 2/3 by counting boxes, but we need to use these numbers here. So we would see that we're counting up 6, 12, and over 1, 2, 3. I would again get that the change in y over the change in x for my slope is 12 over 3, or 4 over 1, or 4. And I could even look at the side and say, okay, I went from 12 to 24, and I went from 1 to 4 to double check that I did not mess up those numbers. I'll show you one more. I can pick, again, any strategy. Some people like to use the original points that are marked here. So they put those intercepts in the table, 0, 300, and 12, 0. I know that I'm dealing with hours and I'm dealing with pages left. I'm actually going to mark some more points here, and I'm going to use ones that are closer together. So I'll use 0, 300 and 4, 200. And I can see that the pages left decreased by 100 when I read for 4 hours. And that would happen over and over and over again. Decreased by 100 when I read for 4 hours. Decreased by 100 when I read for 4 hours until I finished the book. Or you could even mark it on the graph here. This went down 100 and then up 4 hours. In either case, or if we had negative 300 over 12, we'd still get to negative 25 over 1, or negative 25. I'm writing the over 1 because sometimes in the description, it's easier for you if you remember that it's every 1 hour the pages left is going down by 25. So usually we'd say a sentence like, the number of pages left decreases by 25 per hour, or goes down by 25 per hour. If you're having trouble with the sentences, you can use this formula. So as the label for X, so hours reading, as the hours reading increases by 1, the label for Y, so pages left, figure out if it's increasing or decreasing, decreases by 25. This is more like we saw on the graphs without context. As the hours reading increases by 1, the pages left decreases by 25. That way you've used these labels. However, you probably don't always talk like that. You'd say like, oh, my pages left goes down by 25 per hour, something like that. So make sure we pay attention to the scale, so what it's counting by, especially on our real world graphs. Make sure we pay attention to the sign. I highly recommend that you write yourself a little table. You really only need 2 points to find the slope, but you could check it with more points. And that's it. Thanks for watching.